Third example, as shown in the figure, crude oil with the temperature 60 degrees C, with this the specific weight, okay, and with this the dynamic viscosity, as you can see that is about 4 times of the viscosity of water, is pumped across Alaska through the Alaskan pipe at 1,280 km long, 1.2 diameter, is steel pipe at the maximum rate of the Q equal to 2 million per day, or 3.3 cubic meter per second. Determine the kilowatt need for pump that dry the last system, this last system. Okay, that is given the data what we have. That what we want to find the power for the pump in terms of kilowatt. Okay. Next we can start to write binary equation between point 1 and point 2. That is point 1 at the surface of the tanks, and that is the surface of the tanks. And we assume that the Z1 is equal with Z2, so it's cancelled for Z1, and for P is cancelled because it's atmospheric pressure. And we assume that V is the last tank, so is the velocity is close to 0, and the head loss is just the major loss. Okay, the major loss. So we form the both binary equation. We can come up with the head pump is equal to head loss is equal to okay. Next step, we want to find velocity and the friction factor for flow velocity is equal to 2.9 meter per second. And the next step for the steel pipe, open the table 14.1. What is the roughness for steel pipe? It is about 45 10 power minus 5, so we can estimate the relative roughness for this pipe. And next we check the Reynolds number. Is equal to got the specific weight. Velocity and diameter. G and viscosity. About 7.84 10 power 5. Okay, we open for Moody diagram. Moody chart. Okay. What is the F for Moody chart? Okay, we move back to for Moody diagram. Moody chart. So Reynolds number is about 8 10 power 5. Is about somewhere here. Okay, about 10 power 5. the roughness is about this. I think this roughness is 440 and 375, and we got this location for and project to find the friction factor is about 0.0125. Okay, 0.0125. So we can estimate what is the head pump. Substitute our number in here. F is 0.0125. L is 1,280 kilometer. Divided by diameter, and velocity divided by 2g. The head pump is about 6,600. Okay, so that one is the pressure of the pump it should be gamma Q HP is equal to 1.57 10 power 8 meters Newton per sec, or is equal to about 1,157 megawatt. Okay, megawatt. Okay, that is the power that requires 1,157 megawatt. So what we discuss from this is this one is too high. How can we find just such as a big pump like this? Okay, that is, and pressure is too high as well. For pressure is the about 48 megapascal. So that is the too high pressure. You can't find the pipe line that can stand for such a high pressure like this. Okay. So in practical, what we learn from the practical practice, they use instead of they use one pump station, they use 12 pump station. Okay, and they use 4 pump for each location, for each station. And operate for one is for reserve. Working pump is just 3 and one is for reserve. Okay, and the power for each pump is just 10 megawatt. Okay, so the total power 12 times 3 times 10 is about 362 megawatt. If we think about the efficiency, including the water and pump, it's about 60%. So that is we want to power is about 60% of the 362 is 217 megawatt. Okay, so that compared to what we calculate from above is the 157, and this one is 217 megawatt. So that is the practical the way of operating this supply system.